So I want to talk about a very sort of straightforward circuit with just resistors and voltage sources. And this is going to be an interesting circuit because it's a really good example of what you can do with superposition. And so that's kind of where I want to start with this particular circuit. Because you look at this and you go, wow, there's a lot of resistors and voltage sources. Now, no dependent sources, so it's just independent sources. And they could be V1, V2, and V3, and you're thinking, okay, I want to measure this one node voltage here. So how do I think about this? Well, one really interesting way to think about it is by superposition of going, well, what would the circuit look like if I had V1 and I turned V2 and V3 off? Well, then it's going to be V1, and I'm going to have one resistor here plus these other three in parallel. Now, I might want to do this in conductances because it gives me G1 plus in the sum of the three conductances. And you think, oh, that's kind of cool. And so then the relationship I get is G1 over the sum of the four conductances. Interesting enough, for then V2 on and V1 off and V3 off, I get this circuit, which then gives me this structure with G2, and a similar thing for G3. And so the final result that I would get out of this would simply then just be that voltage that I'm measuring is G1, G2, and G3 all over the sum of things. And you think, all right, that's kind of cool. But what it definitely says also is, notice I've got G1 is normalized by the sum, G2 is normalized by the sum, and G3 is normalized by the sum. So what would that look, sum of conductances? Well, notice these are all kiloohms, right? And I could think about this as actually being 1 in terms of conductance, this being a half, this being 1/4. And so if I add all those together, sort of 1 plus a half plus a 2/4 gives me a 2, and then I kind of take that in terms of normalization factor. Funny enough, that means that I'm going to get like 1/2 for V1, 1/4 for V2, and 1/8 for V3 in terms of the way this solves out. By the way, this is precisely the kind of things you might do if I was going to make a digital analog converter, where I might have different voltages here to kind of look at things. In fact, you can imagine if I set V1 and V2 and V3 all to 2 volts, what does V measure give me? Well, it gives me 1.75 volts because I get half of 2, quarter of 2, and an eighth of 2. It gives me 1.75 volts. So kind of neat how you can kind of look at these circuits and sort of by kind of getting the right perspective on it, it very quickly gives you some very, very simple solutions.